This conference will now be recorded.
Good morning, friends. This is your instructor Ishant. On behalf of Auribises, I hope all of you are doing good. So today we're gonna begin with understanding what is an artificial neural network. So this we already have discussed, right? But today, once again, it's gonna be a quick overview on what is an ANN, and we'll see an algorithmic approach that how you actually work with ANN. At the same time, we are going to code the ANN, right? And we'll see how we can work with it, right? So we'll be using some helper libraries like NumPy or Pandas to read our CSV data sets and to resolve the problems, right? So we understood already that your artificial neural network is going to be a network of connected neurons, right, which are going to process the input with the dot product summation function and the activation function. So you can divide your layers into three parts, right? The input layer, the hidden layer, and the output layer. So typically, when we talk about the input layer is a number of features, right? So if you have n number of features in your data set, right, so you got n number of neurons in your input layer. Hidden layer, we can have a multiple layer depending upon how complex the problem is and how we're going to solve it. So there are various ways to come up and take on the call of how we're going to have the hidden layer. Output layer is the number of classes which you are going to predict, basically if it's your classification problem, right? So input layer and the output layer is quite fixed with respect to your data sets, right? Hidden layer is for processing the things internally. So we know what is a perceptron. Perceptron in any of your layer is going to simulate the neuron, right, the nerve cell. So it's gonna have inputs, then we're gonna have weights. There will be a summation function, which is a dot product for your inputs and the weights. And thereafter you have an activation function, for example, sigmoid 1/1 plus e power minus x, right? And you'll have one of the outputs. So typically in a neural network, right? So one neuron will pass the output to the other neuron, and that becomes the input to the next neuron to process, right? And whatever is the expected output, we need to work on that. So therefore, we have an algorithmic approach called back propagation. So where what we do is we tend to feed forward the network. When I say feed forward the network, it means that you are going to put the output of one perceptron as an input to the other perceptron in the other layer, right? For example, the output of input layer goes as input of the hidden layer, and the output of hidden layer goes as the input of the output layer, and thereafter we generate the results. So typically, when I'm going to talk about this back propagation algorithm, we're gonna take up one small, kind of an example to understand how the back propagation will work, right? So in back propagation, what we do is we find the errors, and once the errors are found, thereafter we update the weights based on those errors to minimize the errors. Let's consider this example. So there is an input 0, 1, 2. And there is a desired output 0, 2, and 4. For input 0, you should get 0. For input 1, you should get 2. For input 2, you should get 4 as the desired output. So what we did, we considered the model output with the weight value is 3 for your, let's say, rectified linear unit as an activation function, right? So which says we are going to give the f of x is 0 if it is less than 0, otherwise it is the same value x, right? Assuming that. So the weight is 3. You multiplied the weight 3 with the input 0, you got 0. You multiplied the weight 3 with the input 1, you got 3. Then you multiplied weight 3 with the input 2, you got 6, right? With the rectified linear unit, you got 0, 3, and 6 as the output. But we had the desired output as 0, 2, and 4, and we got 0, 3, and 6. Now we got two solutions here. So in an ANN, either you can work on updating the weights, or you can work on having the bias, and then using the bias you can do some job, right? Now, bias may not be a good choice when the network is very huge, right? Or when the problem is very complex. So what we're gonna understand next is we'll evaluate the errors. We'll go with the back propagation algorithm, which says that let's work on your weights, right? Even if there is bias, we can try to update the weights for the bias, right? So we're gonna work on weights. We'll calculate the absolute error, which is your desired minus, the real output minus the desired output, right? So 0 minus 0 is 0, 3 minus 2 is 1, 6 minus 4 is 2. And the mean square error, or the squared error is going to be just the square of your absolute error. So what is absolute error? It's gonna be your expected value. That's your expected output minus what you got, the measured value, right? Now, what we did, we changed our weight, right? So initially we computed the outputs with the weight value as 3. Now we are going to consider the weight value as 4. So you got the output 0, 4, and 8 now. So how did you get that? So your input multiplied by the weight, input multiplied by the weight, input multiplied by the weight, right? So you got this 0, 4, and 8 as the next outputs. So we are using rectified linear unit as activation function. So the square errors, when we saw, right, they became 0, 4, 16. So typically the errors, they shoot it up. So what we are able to understand is that from our current example, if you increase the weight, errors increases. If you decrease the weight, errors will now decrease, right? So we kind of found a relationship between the weights and the errors, right? So we know that we should not be increasing the weights, we should be reducing the weights if you want to minimize the errors. In our particular example, may not be true for every data set. So guys, back propagation algorithm is the one which is going to update the values of weight with respect to your errors, right? Till time the errors are not minimized in a certain way to achieve your desired output, this algorithm can or may recursively work. So let us consider one more example here. So we have these two layers, right? Two neurons in the input layer and one additional bias, right? So you got this I1, I2, and the bias is 1 with the weights, right? So on and so forth. Your inputs, they also have the weights. Then we got a hidden layer with two perceptrons, H1 and H2. So we got another bias with the hidden layer. And thereafter, we have these two perceptrons O1 and O2 in the output layer, which are going to give us the results 0.01 and 0.9. Now, these are the desired outputs for the inputs 0.5 and 0.10. All right, guys, can I get a smiley here? Is this part clear to everyone? So what is this ANN here? Can I get a smiley as an acknowledgement from all of you? An acknowledgement awaited from everyone, guys. Wonderful. So the next thing in our discussion goes like, we are going to evaluate something known as input for H1, right? Okay, so we got a query from Shimpa. How do we set desired output? So Shimpa, we know our data set, right? So you have your data set. So for example here, so seeds.csv, right? This is a data set. So x1 to x7 are the features and y is the desired output. So we understand that, okay, these are all the features and this one is the desired output. So we already know this from our data sets. So good to go, Shimpa. So we don't set the desired output, we already know the desired output. So basically it's gonna work as in your supervised learning model, where you are training your model with the known data set, right? So that for any unknown observation, you can get one closest match. Now guys, in this approach here, so what we are trying to do is we're trying to evaluate our outputs with our basic perceptron model approach, and let's see how it can be done. So we are going to evaluate something known as input for H1. Now input for H1, the hidden layer first perceptron is going to be your input layer, dot product, and the activation function. So we got W1 into I1 plus W2 into I2. If there is bias, then B1 into the weight of the bias, right? So you got the value. So this is your input for the H1. So we are considering that for your first input layer, perceptron is going to work with the rectified linear unit as the activation function, okay? So whatever is the output, that becomes the input. Same way we have it for output of H2. So this was the input of H1 from the input layer, and the output of H1 is using this sigmoid function 1 upon 1 plus e power minus x, and you also get the output at H2. So we evaluated the output for H1 and H2 with the sigmoid, and output for I1 and I2 with the rectified linear unit, and you got some data here, right? Now we are going to also evaluate the output for O1 and O2. So once again, right, you use the same terminology, the dot product, and at the same time we are going to evaluate the output with the sigmoid here. So you get the 0.75 and 0.77 for O1 and O2. So we got this 0.75 here and 0.77 here. So 0.77, 0.99, kind of okay, near, but for the first case here, it's not gonna work for us, all right? So this is a problem here. So in order to understand, we need to evaluate the errors. So there is something known as mean square error, right? So what we're gonna do is, we're gonna first of all subtract your target minus what actually you got the output, you square it, you divide by 2, right? So you got this desired 0.01. What you got was 0.75. You subtract, you square, so that you get a positive number again, and divide by 2. So you got these errors as 27% here, or 0.27. So same way, error at O2 is very much clear again, 0.02, right? So this error is very much less, but this error is quite huge for us. So you want to minimize the errors now. So model will have a total error structure. So you're gonna add the errors at O1 and O2. So when you add the errors at O1 and O2, so you will get one error like 0.29, right? So you're gonna add the errors together. So this is the error for your entire model. Now what we're gonna do is, we're gonna implement back propagation learning algorithm. So what we do is, the total error which is calculated, we're gonna give it back to the neurons, and thereafter what we'll do is, we'll try to update the weights and see if there is a change in the errors or not for us. So guys, let's see that how it can be done now. So guys, there is one basic mathematical formula. There will be change in the total error if you change the value of weight 5. So changing the value of weight 5, there will be change in the total error. Now the formula says the change in the total error divided by the change at the output O1 into change at output O1 divided by net O1. So when I say net, what is the the previous value which we got, and multiplied by the net of O1 divided by the weight 5 change. So this is one mathematical approach which we have to evaluate first, and once we evaluate this, we'll be able to compute the updated value for the weight 5. All right, so how did we come here? So there is some mathematical derivation to come up till here, right? So let us see. So we're gonna calculate change in total error with respect to output O1, right? So we already have the total error with us, and change in total error is divided by the output O1 is going to be minus target divided by the output at O1, right? So you got this value. Same way, output O1 divided by net O1. Then we evaluate every value, and finally we put them all together in this change in error total, change in weight 5 formula. Once we get this value 0.082 here, right? So thereafter, what we're gonna do is we're gonna evaluate the weight 5 updated value, which is weight 5 minus n times the change in total error divided by the change in weight 5. So you get the updated value of weight 5 here, right? So use this updated value of weight 5 rather than choosing the previous value which we started with an assumption. So similarly, you can evaluate the weights for all other perceptron inputs with respect to your neural network. Once you evaluate these weights, you tend to understand that, okay, now my errors will be minimized, right? So this is your back propagation learning algorithm. We keep on updating the weights and validating if the errors are minimized or not. So for that itself, we have this basic formula to work on. So I'll share this formula sheet once again with all of you over the WhatsApp group, right? So that you can understand it well. Just play around the mathematical part, that won't be challenging for us. So can I get a smiley from all of you? Are we good to go? All right, guys. So the next discussion may be how we can code our artificial neural network, right? So guys, the thing which you need to always understand and observe is that we are playing around here with the ANN model, and what you need to know is how this back propagation algorithm works mathematically. So for that, I'll share a piece of derivation and the work with you guys so that you can go through it, right? Mathematically, you can go through it. So yesterday also we did write our basic functions. So today also we're gonna work how it can be done. So let's say session number 59. So guys, this is the seeds.csv data set. So we saw it yesterday, right? So from where did the reference come up for us? So this is your wheat seed, right? Where we have these different classes of the wheat. So 1, 2, and 3, there are 3 classes. And we're gonna read this CSV file. Then we're gonna create the data set. And after creating the data set, right, so you're gonna work on your ANN model. So yesterday we kind of started how to code it. So today I'm gonna discuss few more things before we start writing the program. So in our first approach is to make you guys understand what is meant by k-fold. All right. So I don't know how many of you have done it, but I'll just take one once again, small brief introduction. Uh, what we have as in what is meant by this approach called k-fold validation. So guys, typically we have the data set. So we have data set, assume 100 observations. So what we will do is we will divide the data set into 4 parts randomly. Now, once you divide the data set into 4 parts randomly, so what happened is, so you got 25, 25, 25, and 25, right? So you got these 25 observations, right? This is known as fold 1. This is fold 2. This is your fold 3. This is your fold 4. Right? So this is the fold and this is number of observations. Now, when I say an observation, so what is meant by an observation? An observation means that you have these labels, right? 1 and 2, which means the value 1, right? For example. So this may be like you got x1, x2, and then the y, right? So 1 comma 2 comma 1. So guys, what we are trying to understand here is that in your observation, right? So you have these data set has 100 records, right? So we divided this part here into 25 set of the observation, and they're randomly done, right? So they are randomly done. So you have 25 features and 25 your targets for the set of all these four folds. Now what we'll do is we will train the model with all the four folds so as to have a much better accuracy as compared to previous approaches. Let me come up and tell you what we are doing here. So in previous approach, if you have 100 observations, for 100 observations, what we did, we divided into 70 is to 30, right? So 70 for training and 30 for testing. Now in this our k-fold approach, right? So in k-fold approach, we are using all the records, right? We're using all the records and dividing further 4 of the records as testing and training. So it means what we are going to have is we are going to have a much better accuracy. So 25 observations here. So these are the number of observations, 25 features, Sahil. So when I say observation, right, so this is the entire observation, x1, x2 along with the target. So let's say in the seeds.csv, right, so you got these 210 records. So in the k fold, randomly we are going to divide. So this may be the fold 1, this may be the fold 2, this may be the fold 3, fold 4, so on and so forth, right? It depends upon us. So guys, are we clear? But that will be like randomly done for us. Guys, can I get a smiley from all of you? What is meant by the k-fold observation structure? Let us try to solve the same with one of the discussion, right? I'm gonna say import numpy as np. Let's take one example if you want. And I'm not going to write the program. I'll just explain you with sklearn's model selection. So from sklearn.model underscore selection, you imported the k fold. So you have this x as np dot array. So I'm gonna write an array. So this is going to be a list of lists. So we got 1 comma 2 as first feature. Then let us take 3 comma 4 as another feature. Then I'm gonna take 1 comma 2 as one more feature. Then 3 comma 4. So these are your x as features and y as, let's say, np dot array. So I'm gonna take the labels 1 2 3 4, right? So these are the inputs and these are your targets, the features and the targets, right? I hope this is clear to everyone. Now this is the data set available for me. All right, so this is the data set available for me. So how many observations are there? So if you see this data set quite looks like 1 2 1, right? And then we got 3 4 2, then we got 1 2 and 3, then finally we got 3 4 and 4. So this is your x1, x2 and the y. Guys, I hope this is clear to everyone. The data set is clear to everyone, right? Can I get a smiley from all of you? We're using a very small data set to work on. Now what I will do is I will create an object of k fold. So you say k fold is k fold, and you say that we want the number of splits as 2. So I want to divide my data set into two folds. It means it's gonna have 50% observations and 50% observation, right? Two folds of 50% observations. So if you want to know the splits in the k fold, so I can anytime say print k fold dot get the number of splits, right? So splits. So you got this query, you got this program in execution. So there are two splits now in the program. So in the next approach here, what I will do is I will just come here and say for train index comma test index in your k fold dot split. So you're gonna split your x and y, right? So guys, we will say split x comma y. So what you will get now when you will split your x and y, right? So you get these training indexes and the testing indexes randomly. So if you want me to print this, I'm gonna say print me the train index and the test index. So I'll just say print. So these are your indexes, right? So these are the indexes which we are going to print first. Now I'm gonna divide my data set. So we have this x train comma x underscore test, which is going to be your x of training index, then comma x of testing index. Same you will have y training and y testing with respect to your train index and the test index. So randomly you will get the indexes. So when I'm saying indexes, what does it mean now? It means this is 0, 1, 2, and 3, right? So these are the indexes. So the data set will be split randomly on these index approach, on the basis of index, right? So data set split happens on the basis of the indexes for the data set, right? Now what I'll do next is I'll just print out this x train and x test. So printing this x train and x test and printing the y train and y test. So this is your fold, right? All right, so let's now run the program. So what you will observe over here is there were two splits. So in the first split, we got the indexes 2 and 3. In the second split, we got the indexes 0, 1. So we got this data set. So 2 and 3 is your first fold, 0 and 1 is your second fold, right? So randomly. So this will be always chosen randomly for us, right? Now for my fold, so I got this 2, 3 and 0, 1, right, in the first part. Then the second part I got 0, 1 and 2, 3. So guys, over here when I'm printing the training index and the testing index, so training index is 2, 3. So it means your x1 x2 is gonna be 2, 3, but we got the testing index from 0 and 1. So the other way it is 0, 1 and 2, 3. So that is how we got this data 1, 2, then the 3, 4, then 1, 2, 3, 4, and 3, 4, 1, 2 for their 3, 4, and 1, 2 for their corresponding observation set, right? So that is how we are working on this approach. If you can just correlate your data set so you understand now that how the k-fold approach is going to work for us. So I would like to get a smiley as an acknowledgement from all of you. In the meanwhile, I'll also share the program over the chat so that you can understand it. If you want to execute, you can execute at your end at the same time. So Gagan, Hitali, Japjeet, Jasnu, Kamal, Lakshay, Manmeet, Navjot, Pradeep, Pridham, Roopkaval, Sahib, Sahil, Saloni, Sarthak, Shalu, Shashi, Shipali, Shimpa, Shivani, and Soumya, guys. Are we good to go till here? An acknowledgement awaited. What is this k-fold? So we use this k-fold approach majorly while writing your ANN models so that we can achieve a better accuracy while we are training the models, right? Wonderful, guys. Thank you so very much. So let's now move ahead. So yesterday we chose seeds.csv dataset. So we wrote a program in session number 58.py where we came up in dataset preparation for our ANN, for our artificial neural network. We wanted to come and somehow prepare this basic, you can say, model, right, for the dataset. So we have this class dataset helper, which is reading a CSV file. So we will give the input as file, and in our input file, what is the target column, and would you like to normalize your data set or not, right? So we already have covered this normalization technique. So the first thing is you read the CSV file. Once you have read the CSV file, thereafter what we are going to do is we are going to know what are the target indexes. This we already covered in a way, right? So I'm just reviewing it. I'm not writing the code again. So what we'll do is in the data frame of target.values, we created a set and then we created a list. So why we did the set? So that we don't have the duplicate values, and we sorted them. So we got the indexes here, right? So we got the target indexes here. Then we dropped one of the columns, right? So df.drop, that is like the target. We drop the target column. Axis 1 means you are going to drop the target column with the axis 1, right? So 1 means column. So you got this guy called X. So X is what, right? X is all of your features. And we said Y is numpy.vectorize. So we are going to use these target indexes, right? And we're gonna get the values for your Y. Same way in the target indexes, we got dictionary of key value pair. So we'll get the number of classes, or we get the classes in these target indexes as the keys, right? So the length of target indexes will become the number of classes. And if you want to normalize, so there's an approach called standardization, x minus mean of x divided by the standard deviation in the x. So as discussed in our previous discussion, right? So you return x, y, and the number of classes from this CSV file. So what I'll do is, let me come here and write this session 59A. So I'm gonna import pandas as PD. Then I'm gonna import your numpy as NP. So guys, yesterday we wrote the programs in 3 different files. Dataset helper was a different file, then ANN was a different file, and main we wrote in a different file. So today what I'm gonna do is I'm just gonna combine them in one program. So this dataset helper has a class, right? So I'm just gonna copy this class. So here we are with the dataset helper class. Let's have a quick look on this. So init function, right? As in your constructor, we have nothing here. So we are just going to prepare the dataset. That's what I'm printing here. Reading the CSV file, right? So you get the value X, Y, and number of classes. And we have this K fold cross validation function written ourselves. So I wrote a small algorithm here. So randomly, first of all, we got all the indexes of your data set, right? And thereafter we created a list of index folds. So how many index folds you want, right? So you want n is the number of observation. So I'm just gonna mention here. So n is a number of observations. in the data set, and folds represents how many splits we want. So that is how we are iterating in the number of folds, and randomly what we are doing is we are picking up the data from these random indexes, right? And thereafter we are appending the same in this index fold list, and we are returning back the index folds, right? So it's gonna be a list of 4 arrays. So let me come here and create this main function, and let us execute the main function like this. So what we are going to do here in the main function, guys. So in my main function, so I have to do couple of sequences here and there, right? So the first thing first is that you choose the file name. So the file name is going to be this seeds.csv as the file name, right? So I create the object of this ds helper class, dataset helper class. So I'll say ds helper is a dataset helper. The moment you create the dataset helper and run your program, it says preparing the dataset, right? You get a message. So you need to execute few more snippets here. So it's gonna be your ds helper dot read the csv file. So I have the file here. So what is the target? So guys, the target is going to be this column called y, if you see. So I got x1 to x7 as 7 columns, and y is going to be my target. So coming here, so the target for us is going to be y. That's like the column, and you can just come here and say file is this file name. And lastly, if you want to normalize, you say true. So normalization will always be a better approach, right? You can have the standardization on the data set, and that of course enhances the accuracy and minimize the losses, as we have seen in our previous discussion. So you read the csv file, and when you read the csv file, you get these 3 things: x, y, and number of classes. So let's have them. So reading the csv file, you get this x, y, and number of classes, right? So I'll say print me x, print me y, and print me number of classes. So this is like printing the data set, right? Seeds data set. But remember, this is what we have read, and we are just giving it back, right? So we are trying to do certainly what your sklearn library does, and what your other Keras will do. So you have this seeds data set, you have this features, you have these labels or the targets, right? 0, 1, and 2 as your classes. So they are total number of 3 classes. So guys, can I get a smiley here? This part of discussion we did see yesterday, but at the same time, I'm just making you a bit, kind of an overview on what we did yesterday, and I am doing it in the same file. Okay, so this was the dataset helper to begin with, right? We got the dataset read, and the next part for us may be something more, right? So we'd like to come and create the folds, right? So I want to have a kind of folds for us. So now I'm going to say, I'll just write one print statement here. Print. So creating folds for n records, and I'll just put here your, so creating n folds for, creating folds for n records, right? So this is what we'll be getting here. So this is preparing data set, and for here I'm just gonna come and say, so processing file to prepare X, Y, and number of classes. So whatever is this, kind of statement which will be printed, this statement will come from dataset helper. Okay, so I'm just using this kind of a tag here, dataset helper. All right. Now, when you run this code here, so what you find is dataset helper preparing the dataset helper processing seeds.csv to prepare X, Y, and number of classes, and this is the result, seeds dataset. If you want to just put this part here, so X is, then you can have Y is, then you can have number of classes is, right? So this is what we just did, right? So seeds data set. Now in my next discussion, I am going to generate splits for this data set, right? I want to split my data set into let us assume that if you want to do a split, right? So we'll split this record into 4 different folds, right? So we have these approximately 210 records, right? So we'll try to generate folds, 4 folds for the data set, but at the same time, right, you can even generate more folds or lesser folds. It's up to you. So we'll have some optimal, kind of 50 folds for the data set. So for doing that, the first approach for me is to come up and have all the indexes, right? So I'll say index underscore all is your np dot a range. So I'm gonna create a range from 0 to your even before that. So what I'll do is I'll say number of observations. So how many total number of observations are there, right? And comma, how many input features are there, right? So that I'm going to say x dot shape. So guys, what is this shape, right? So shape is going to come up and give me, so just give me a moment here, x shape is comma x dot shape. So I'm just gonna print this x dot shape for you. All right, so just give me a moment here. So you run the program here. So what you find is the shape of x is 210 comma 7. So what you get here now, right? So you understand that 210 are the number of observations and 7 are your features, right? So x1 to x7. Y is not included in x, right? So you already pre-process your data set here. So y is this guy, right? And I'll also print the shape of y so that we understand what is what. So y shape is y dot shape. So we got these two numpy arrays, right? So x shape is 210 by 7, 210 cross 7, and y is only 210. So there are only 210 rows in one single column. Now number of observations and input features is going to be your x dot shape. So when I say this part here, so if I'll print these number of observations, and if I'll print these input features, so what I'll get is I'll get 210 here and I'll get 7 here. So guys, can I get a smiley from all of you? So I hope this is clear to everyone, right? So here we are, right? Number of observations 210 and input feature 7. It's good to go with everyone, right? No challenge here. Wonderful, guys. Now when I say the next part is to create this k folds for my data set. So I'll say index underscore all, which is np dot a range, and we have these number of observations, right? So let me print this index underscore all. So when you run the program, so this is like all indexes. So when you print these all indexes, so you got 0 till 209, right? So you just got one a range function, and you got a list of indexes for your data set, right? Because in the seeds.csv, I don't have the indexes here. What I do have is records, but we need to write these indexes ourselves, right? So why I want indexes? If you can recall how the k-fold algorithm will work, right? So it will split the data, and you get the training index and the testing index for your data set, and from there you create the training and the testing data. So this is the reason why we want the indexes for your data set. We don't have the indexes in the CSV file, right? If you have it as a column, you are lucky. Now the next is what? To my dataset helper, I will just say k-fold cross validation. Now, what is this guy n for me? N for me is number of observations. So number of observations, and I'm choosing the value for folds as, let's say, 4. So I want 4 folds from the k cross validation for these number of observations. So I have the n as number of observations, right? And we got all the indexes here, 0 till so I'll say for 210 records, we have indexes as in 0 to 209, right? So this is what we got. Now k cross validation is going to give me these list of index folds, right? So it's gonna be a list of index folds which is going to be returned back. So what I'll do is I'll say that, okay, we have index underscore folds. Let us print these index underscore folds. Okay, so these are all indexes, and same way what I have is we have fold indexes. Print me index underscore folds. So let's run this program. So my algorithm is going to create 4 folds for 210 records. If you see this guy, which we did in our yesterday's discussion at the same time, right? So we are generating these 4 folds for 210 records, and these were the total indexes 0 to 209. The first fold has these random indexes. If you see now, the highlighted one, 44, 188 till 190. This is the second fold, the array, if you can see, the third fold and the fourth fold, right? So what we got these random indexes from the data set in 4 different subsets, you can say, right? So we got 4 random folds indexes with which we can prepare our data set. A smiley awaited from all of you in case we are clear till here, guys. So if I'll say print me the length of index underscore folds, so what you gonna observe is that the length is coming out to be 4, right? So you have indexes, you don't have data here, you need to understand, right? So as of now, we got overall indexes and we got folds for us. So we are now fully prepared with our data set. So till here we are done with our data set. So what we did, we read the CSV file. So after reading the CSV file, you have data in X, Y with number of classes. Moving ahead, you have divided your data set indexes as in fold, but we haven't created our training and the testing splits, right? So you got this part, you got the training index and the testing indexes, but we haven't created X train, X test, Y train, Y test. That is something which is still not done, but we have played around with our data set helper class. We have utilized it. Now the next part of our discussion was to create the ANN model, right? So guys, yesterday we wrote this class ANN. So in the ANN class, we had the init function, which will take input, output, and the hidden layers. We'll have the fit function, where we have this X, Y, and epochs. Then predict, to predict the output. We got feed forward, feed backward, update weights. Then the summation function, sigmoid activation. We even use this sigmoid activation derivation. So we'll see why and when we can use it, and one hot encoding scheme. So these are some utility functions with respect to your ANN class. But we haven't written anything in this class ANN. Okay. So I'm just gonna come here and use this another class called ANN in our today's session. So this was my dataset helper, and here we are going to have this class called ANN. All right. So this is all empty for us. So in my main function, I have done so much of the tasks in now. Now let us see what can we do with respect to our ANN. All right. So I'm going to write this for loop for I, comma, index underscore test in enumerate index underscore folds. So what I am doing here, we are iterating in index underscore folds, right? And I will range from 0 to 3, as we have 4 folds. And next is index underscore test will have the random array indexes in the fold. So just to proceed here, I'm just gonna say print me I, and then print me index underscore test, and thereafter I'll just do an empty print line, and we are just going to say print, and here I'm gonna just say iterating in folds. So you run the program. So what we got is this was the folds which we created, 4 folds. For 0 fold, you got 44 till 190. So that's like your first part, then the first index, then the second, then the third. Guys, a smiley waited in case this for loop is clear to everyone. I hope this is clear to everyone, right? What is this guy called index test and I? Great. So this is my testing data, right? So this is going to be the indexes for the testing. And how about the indexes for the training, right? So even I need to get the, these are the indexes for the testing data set. How about the training data set, guys? Can I get a smiley from all of you? Is the question clear? So index underscore test is array for testing data set. Training data set would be all minus test. That is, when I'm saying all minus test, right? So I'm trying to put up here the usage. That's like index underscore all minus index underscore test. How many of you are good to go with this part here, guys? Or if you didn't understand, so I got these all indexes, right? So from these all indexes, if I subtract these indexes, so the remaining one becomes the training data set. Can I get a smiley? So I'll use the numpy in action, right? So I'm gonna say, so the way you got index test, I'm gonna have index train, which is going to be np dot delete. So you delete what? From all of your indexes, you delete these tests, right? So this test indexes you are going to delete, guys. Can I get an acknowledgement? Smiley waited from all of you. So we got index test, and now we even have this index train. It means when my loop will run for 0, 1, 2, and 3, I have 4 folds. I have 4 testing indexes and I have 4 training indexes. Now moving ahead here, so I'm gonna say x underscore train comma y underscore train. So x train and y train is going to be your x of index underscore train comma y of index underscore train, so on and so forth. Your x test and y test will have index underscore test and index underscore test here. So we will have 4 folds where we are having our data set randomly divided with testing and training data set. Guys, this is what we did, right? So you got the x train, y train, x test, and the y test. I think this is clear to everyone. All right, guys. So what is the next discussion for us, right? So we got this guy called ANN. I need to create artificial neural network, input layer, output layer, and the hidden layer. Now I will say model is the ANN. So you wrote one artificial neural network. What is the input here? The input for me is going to be input features. So the value of input features was 7, right? So input features value was 7, if you can recall. Then the next thing for me is this guy called output, which is going to be what? So output is going to be number of classes, if you can recall, guys, right? So we got this number of classes here. So these are number of classes, they are 3 for us. So total number of classes. So we got 7 perceptrons in the input layer. We want 3 perceptrons in your output layer. And for my hidden layer, I'm just going to pass a list for, let us say, 5 nodes. So I'm just going to have these ANN with the hidden layer as 5 nodes. Okay, so why choose 5? Why not choose any other number? Or here you can even go with the 4, you can even go with the 40, right? That's up to you. But we'll see in our future discussion, right, how you should be working on the hidden layers. Not now. The next part for us will be model.fit. So you want to fit the model. So with the training data, if you see over here, when I say model.fit function, so you need X, Y, and epochs, right? So in the model.fit, I'm going to pass the training data. So you're going to have this X underscore training data and Y underscore training data, and I'm going to choose the value of epochs. So let us say 25 epochs, right? So this is your X, this is your Y, and this is your epochs as in 25. Model.fit. Next part is what, right? So this is like creating the model. Now this is like training the model. So we haven't written the code. So how to train the model? We haven't written that code, okay? So this fit function, init function, we have not written the code, but we understand it from our sklearn and from our TensorFlow approach, that how we work, right? So we need to create the model. So creating the model, training the model, and of course, yes, once you have trained the model, you will get the predictions, right? So I'm gonna say by prediction on the training and by prediction on the testing. So that's like your model dot predict. So you're gonna predict on what? You're gonna predict on your training data. So this is like X underscore train, and for so you got the actual predictions and you got the predictions for your testing data set, right? So what we are doing is we are making the predictions. Make predictions for training data set and testing data set. So that is what, right? So that is original Y and predicted Y on both training and testing. Guys, a smiley awaited here. So predict function we haven't written, right? But we know that there is a function which should be called, right? But we haven't written the program in that. Okay, so Shashi says, what is by underscore train? Just give me a moment. So your query is here, right? So is this the query here, Shashi? Okay, so assume this is your X training. So these are X1 to X7, line number 2 here. This much highlighted is your training X train, and this is your Y train. This is your X test, and this may be your Y test. Good to go. X train, Y train, and X test and Y test, right? Wonderful. So we got the predictions. Now what I'm gonna do is I'm gonna evaluate my accuracy score on the training, accuracy training score, which is going to be what I'm gonna do is I'm gonna first of all say 100 multiplied by np dot sum of y underscore. So we have this, just give me a moment. Okay, so this is the y training is going to match y prediction training. So guys, what I am doing is wherever the prediction in the training, right, exactly matches the data in the training, So you sum up those observations, right? And I'm going to divide by the length of y underscore train. So very basic mathematical model. So let us say out of 100 records, only 50 were giving us the correct results. So you are matching which are giving me the correct results here. You are summing those records, dividing by the length and multiplying by 100. So you get the accuracy score, right? So the way you got the training score, in a similar way you got the testing score, right? This is going to work on my testing data set. So y test divided by the length of y test. So I got these two accuracy scores. All right. So I'll just come here and say print me model accuracy on the training data set. So we got the accuracy on the training data set, and we got the accuracy on the testing data set, right? So you got training accuracy and the testing accuracy. So guys, are we good to go till here? The training accuracy and the testing accuracy. So how many times this accuracy will be evaluated, right? So loop will run 4 times. If you see now, loops gonna run 4 times since you have 4 folds. So there will be model which will be created 4 times, but with the different training and the testing data set. So there will be 4 accuracy scores for the 4 different folds. So what I'll do is I'll just come here and say accuracy scores is a list, and this is going to be accuracy training scores and testing scores. So I got these two lists created. So what I will do is I'll just come here and say accuracy training scores dot append all right, so here we are. So accuracy training scores dot append the accuracy training score, and same way the testing scores here should append the testing score, right? So you keep on appending the data, and once you come out of the loop, right, for so we got this index I, right? Same way we have this guy for so this is for the index I, right? So for the ith iteration you got these scores, right? Now coming out of this, so I'm gonna say model accuracy for the training on the training data set. So this is going to be your sum of, right, sum of your accuracy training scores, and what you're gonna do is you're gonna divide by the length of accuracy training scores. Same way model accuracy on the testing. So this is going to be the testing scores of the sum divided by the, so this is overall, right? So printing overall model accuracy over 4 iterations. Outside the loop, I have just summed up the training scores divided by the length, right? So you got an average. over the 4 iterations. Guys, can I get a smiley once again? Are we good to go till here? So now we are left with writing the fit function, predict function, right? These summation, sigmoid, one hot encoding, etc. and etc. I think till here we are good to go. We have finished our main function. We already have the data set. We are iterating in the 4 folds, and we are creating the models, predicting the data, and we are just now left with writing our ANN. So in the OOPS model, you need to write your ANN class now. Anyone with any query here? So I'll just give you this code over the chat. I would like you guys to take a moment and review the same. So please take this code from the chat box and let me know if we are good to go here. So guys, can I get a smiley as an acknowledgement? Are we good to go? Anyone finding any challenge here in the program can please ask. So we are creating or we are developing this entire program in parts, right? So we will not be putting up all the efforts, but at the same time, so few of these functions in the ANN we can code now. So how we'll come up and code the summation function? I think this is very much easy. So guys, I'll just say return me. So sum of, I'll create one list here and I'll write a list comprehension I into W. So weight multiplied by the input for I comma W and in the zip of inputs and the weights. So what zip function is going to do for me, right? So let's say you have inputs. So assuming this part here, all right, so let's say you have the inputs over here as what, right? So you have inputs as a list where you got the data coming as 1, 2, 3, 4, and 5, and the weights are by default assumed to be 1 for all, right? Assuming this part here. So zip function will do what? So zip function is just going to be giving me a list of lists 1 comma 1, 2 comma 1, 3 comma 1, 4 comma 1, and 5 comma 1. So if this is 2 and this is, let's say, 2, so this is basically 3 comma 2 and 5 comma 2. Guys, can I get a smiley for the zip function? So this is what we're doing here is the dot product, right? This is the dot product which we are doing here. So input into the weight, you are going to sum them and return it back. That's the summation function. And your sigmoid activation function will receive an input as sum. All right. So the input as sum which this guy is going to receive, I'm going to return 1 divide by 1.0. Let's say divide by. So I'll just import one more class here. That's like math. And guys, if you can see now, right? So we didn't import any scalar, any TensorFlow, Keras thing, right? We just have this pandas, NumPy, and the math. I guess I can import something known as random, right? So we'll even use the random library. So 1 divided by 1 plus math dot exponential of your minus of the sum, right? So this is what is your sigmoid function, 1 upon 1 plus e power minus x. And the sigmoid derivation is going to take one sigmoid as input. So you're gonna return back sigmoid multiplied by 1 minus the sigmoid, right? So this is what the sigmoid function is going to do for us in the derivative environment. So we got summation, we got sigmoid activation function and sigmoid activation derivation function. So 3 things I have written here. And the next thing which I'm going to do is in my ANN constructor here, when I say ANN model created, I will say self dot input is input. So we use our basic OOPS approach. Self dot output is output and self dot hidden is hidden. And I will say there is a network, ANN network, which is an empty list, right? So ANN model created. So ANN model created. So we'll just put here ANN model details. So this is coming from the class ANN. So I'm just going to put it like this so that we have a discrimination what is from the dataset helper and what is from the ANN. So details, they go like, we have the input, we have the output, and we have the hidden. So dot format, you say input, output, and hidden, right? So we even have this network as an empty list to begin with, right? In a model, network is going to be your self dot network comma length of self dot network. So to begin with, so we're gonna have a network with a length as 0, right? So if I just run this program, so what you see is ANN model created, details, input 7, output 3, hidden 5. So in a model, network is empty with the 0. All right. So this is going to happen in 4 iterations. For the 0th iteration, we created the ANN model. So for the 0th iteration, we train the model, predict the model with the different training and testing data set, so on and so forth for your first iteration, second iteration, and the 3rd iteration. So in the supervised learning model, I am going to have my data set and I'm going to use my entire data set to train and to predict to achieve the better accuracy results. Can I get a smile from all of you? So we wrote a part of our ANN, which I hope is clear to everyone, right? So tomorrow we're gonna build this network. We're gonna write the fit function, maybe the feed forward, feed backward, update weights as well, right? So it will depend upon how we can proceed. So this is all for the day. I'm just gonna push the code. ANN in making. This is part 2. So commit and push. So yesterday we wrote these snippets in different files, right? So what we'll do is, once we create our entire model, we'll try to again split them in different files and see how they work for us, right? So we'll try to write the similar things, but I'll do it with the packages in our final snippets. So anyone with query can please raise the same, guys. I hope we are good to go, and I hope you have enjoyed this part of ANN in making, right? So this is no doubt about the fact that is going to be a wonderful program for all of you. So this will be all. And yes, of course, guys, uh, just subscribe the YouTube channel, right? Be aware with the notifications, and do share it across with your friends as well in this time of lockdown, so that even they can just, kind of get few inputs here and there. So thank you so very much. Bye bye, guys.